A student prepares 100 milliliters of saturated solution in magnesium fluoride by adding 0.5 grams of solid of magnesium fluoride to 100 milliliters of distilled water at 25 degrees Celsius and stirring until no more solid dissolves. Assume that the volume of the undissolved magnesium fluoride is negligibly small. The saturated solution is analyzed, and it is determined that fluoride in the solution is 2.4 times 10 to the negative 3 molarity. The first part says write the chemical equation for the dissolving of solid magnesium fluoride into water. So you start off with the magnesium fluoride. Because it's solid, you put the S in parentheses, and the reaction also can be reversed. And even though magnesium and fluoride are liquid, it's also soluble, so you would put the AQ. Question number 2 says calculate the number of moles of magnesium fluoride that is dissolved. In the question before, it said it had 1.4 times 10 to the negative 3 moles of fluoride. So you would divide it by 1 liter, and also because there is 100 milliliters of the solution, you would multiply it by 0.1 liters, so you could convert it. Because you have liters in both the numerator and the denominator, the liters cancel out. And then if you do the mole-to-mole ratio from the equation, there's 1 mole of magnesium fluoride and then 2 moles of just fluoride. And so you multiply these two together to get 0.2 times 10 to the negative 4 moles of magnesium fluoride. Part 3 says determine the value of the solubility product constant KSP for magnesium fluoride at 25 degrees Celsius. So you have the magnesium, and if you do the moles, 1 magnesium equals half of a fluoride and also half of the moles of fluoride. So the KSP concentration times the fluoride concentration to the second power equals 1.2 times 10 to the negative 3 times 1.4 times 10 to the negative 3 squared. Because of the previous calculations before, that's where we got that answer. And then altogether that equals 6.9 times 10 to the negative 9th power. For part B, for question 1, the beaker contains 500 milliliters of the solution in which both calcium aqueous and barium aqueous are present in a concentration of 0.1 moles at 25 degrees Celsius. A student intends to separate the ions by adding 0.2 molarity of sodium fluoride solution of 1 drop at a time from burette at 25 degrees Celsius. The value of KSP for calcium fluoride is 3.5 times 10 to the negative 11, and the value of KSP for barium fluoride is 1.8 times 10 to the negative 6. Part 1 says, which salt will precipitate first of calcium fluoride or barium fluoride? Justify your answer. Calcium fluoride will participate first because its KSP value is smaller, therefore the ion concentration product of calcium and fluoride will be first exceeded the KSP value. For parts B2 and B3 below, assume that the addition of sodium fluoride solution does not significantly affect the total volume of the liquid into the beaker. Part 2 says calculate the minimum concentration of fluorine aqueous necessary to initiate the precipitation of the salt selected in Part B. So the salt in Part B1, we selected that calcium fluoride would precipitate faster, and in the question, it said that it equaled 3.5 times 10 to the negative 11. So the KSP equals 3.5 times 10 to the negative 11 equals the calcium and the fluoride, which equals 0.1 equals the fluoride. So then you have 0.3 times 10, because if you multiply these together, it equals 0.3 times 10 to the negative 10th power equals fluoride squared. So you would take the square root of both sides, which just leaves fluoride, and now you have 1.9 times 10 to the negative 5th molarity, which equals fluoride. Part 3 says calculate the minimum volume of 0.2 molarity of sodium fluoride that must be added to the beaker to the precipitation of part B1. So you start off with a proportion of 0.2 molarity of volume times 1.9 times 5 to 5 liters. So you divide both sides by this number, and they cancel out. So then you put this in the calculator.